start collecting some users. So after today, it should be easy to install an instance. And I'd like to, if we have time, just add a bit more to the Firebug dev system as an example. Okay, so from last week, I had an agenda. So I realized the installation was too complex. So I added another layer to walk the user through an installation procedure. And this sort of illustrates how I envision users walking through when they interact with new components through the command line. So it's going to prompt the user and so on. So I want to just recap the whole workspaces concept. So on my system, I have a bunch of workspaces. Oops. Called Genesis, Genesis Demo, Genesis EXT, Genesis Live. So these are different groups of workspaces. And I have them the root so that I can get to them quickly. So we are now in one of the workspaces called Genesis Demo. And in that workspace, we have two systems cloned. So we are in Genesis Demo, and in there we have two workspaces cloned, DevComp and Firebug. So this is consistent to the way the Firebug system is designed to be set up. So if we go to Firebug Dev System, and here it says, so you create a workspaces directory, then you clone Develop Companion, and then you clone your project you're working on, and in this case it's the Firebug Dev System. So to set up Develop Companion first it's much more simple now. So you simply clone Develop Companion, you call install, you call activate, deploy, and then you can open the admin system. So I've already done that for here. So if I go PIO open, I can get the admin system. Now the difference is before we were using host names and it required a DNS service. So I've now gotten things working on strictly an IP address. So this is more useful now if you have lots of disposable servers and you don't actually need DNS entries. We can now bring up full instances just running on IP. And obviously you need to have all the ports open to the world. But the security layer will be built in through session cookies and so on, which is already working. So that's how this works as well. But so we can now run on host name or IP. So that was an important change. So once the Developer Companion system is cloned, we now clone the Firebug system, and that's the process I'm going to go through right now. So in this documentation here comes directly from the upstream project, the workspace project. So this project I'm maintaining as an example of how someone can set up sort of a peer project to Develop Companion, and I'm simply merging that into this Firebug dev system. So this README is more generic and not necessarily targeted to the Firebug dev system. We can look at changing that and getting a more user-friendly experience for Firebug people by providing a little bit more concise instructions on a different site. And we can put that on the instance, and I'll work on that. So, okay, so the Firebug dev system. So what we want to do is, after we've cloned Developer Companion, we're in Genesis Demo Firebug. Well, let me go up one. So we're in Genesis Demo, and I'm just going to delete Firebug. Okay, so we've done step one. It's all working, it's all deployed, and then now we're going to do step two. So we're just going to go git clone Firebug. So I'm going to clone here, git clone dev system, and I'm going to rename it to Firebug. So that clones the Firebug dev system. Then I go into Firebug. Okay. So now I'm in Firebug, and then it says we have to set up some PIO credentials. So that is already done. So if we look at more pio.json, we can see that I've configured here already by default in the repository a domain which is arbitrary. I guess that can be out. If we run by IP, we don't need, well, actually it needs it for the host name. And then we have, so I'm actually going to change that to firebug.io or something like that, whatever domain we can pick to run the Firebug system on. And then we have a namespace of Firebug. So you don't actually need to modify this. This is automatic. So after we've cloned it, we just call bin install. And bin install will now do a few things. So it's switching the environment, checking if we have NVM, enabling Node if Node is not on the path. Then it's going to initialize submodules if they haven't been initialized before, install the dependencies, and then download the catalog and install all the catalog. And since we are running in a sibling workspace, it's going to link all the packages to the developer companion clone that I have here. And now everything is installed. So if we look at the file structure now, we have a new directory called upstream, no modules, and this extends was downloaded as well. So the next step is we simply call source bin activate. So we go source bin activate. And this now is the new procedure that the user is going to be run through. So I called bin activate. It's going to switch environments, enabling Node again. And then it didn't find an environment configuration file in the workspaces directory. So we're in Genesis demo Firebug, and then Genesis demo firebug.activate.sh is where we keep environment credentials, say for the DigitalOcean API keys and so on. So it says it didn't find it, it's going to create one. So it is recommended that you use dedicated accounts for each of the following environments. So I kind of work in 3 environments. I have a playground environment, a development environment, and a production environment. And the idea is that the playground environment, and these are all dedicated accounts on DigitalOcean or AWS or whatever. So the idea is the playground are highly disposable instances for quick tests and so on. Development is more in-depth instances that are more stable for ongoing development. And then you have your production instances that are totally locked down to clusters and so on. And these should all be separate accounts. And in the beginning, I recommend that you use a dedicated account for Devout Companion. It's not going to mess with the existing instances, but just in case, it just makes sense. So, okay, so then it can run you through, and you have an interactive interface to configure now the instance to deploy to one of 2 services. So I have DigitalOcean and Amazon Web Services. So I'm going to select DigitalOcean, hit enter, and then it's going to ask me, let's put it up here, then it's going to ask me, enter the email address for a DigitalOcean account that you want to use. So I already have a DigitalOcean account created here, and I'm just going to enter my email address, my client ID, and my API key. And once I do that, actually I'm going to create a fake API key so I can show you the files. Okay, so I put a fake API key in, hit enter. And now if we look at this, it now created 2 files. It created firebug.activate. So these are the DigitalOcean environment variables, so email, client ID, API key. These are the PIO credentials. So these are the unique IDs that automatically get generated to create a unique instance for you. And then I have a new variable called PIO profile path. And this is a provisioning profile that can get overlaid gets overlaid on top of the pio.json file. So we have this file, and then the firebug.profile gets overlaid, and here we're defining config pio VM, and we want to use the adapter DigitalOcean. So depending on which adapter I choose here in the command line, it'll configure this profile and then provide the correct activation files. So this is now an interactive way to first configure these files, And then further tooling will allow you to modify these files either locally or syncing through a central service, so you don't even have to do any manual configuration. But this now is quite flexible for sort of ad hoc deployment of instances. Okay, so I'm going to just remove those again. Firebug star. Okay, and then I can just call source bin activate again, and then it'll say, oh, didn't find it, so we're just going to do it again. And this time I'm going to use real credentials. So email, client ID, API key, enter. Okay, now we can call PIO deploy. So that was the next step on this dev system. We call PIO deploy. So call PIO deploy. So now it's going to say creating private key path, generating private key path. So it's going to create a private key based on the host name. So this is the namespace, and then this is the domain. And we should create a nice domain for Firebug for this dev system, like firebug.io or whatever we want to call it. And then people can get automatically host names on that main namespace, and we can even give off DNS host names for contributors and so on. All this can be layered in. And then it generates the public key from the private key. Then it creates the VM on DigitalOcean, and now it's waiting for the VM to boot. So 3%, 90%, and if we go to DigitalOcean now, we should see that it's booting. There you go, Firebug. And as soon as this is finished, it's actually going to start provisioning everything on the instance now. So now the instance is here. This should check again in a minute. So there you go. So now it's going through and now provisioning all the services. So this is going to take a couple of minutes, and we'll come back to it once everything is provisioned. So that's the installation procedure now, and this is a little simpler, I think, and there needs to be no reconfiguration. And what I mentioned before with these things, this is just because it's in the generic README, and this is already updated for the Firebug system. So it's a matter of running a couple of commands and then answering a couple of questions, and then you got your instance up and running. Okay, so that's the generation. So we'll leave that going. Okay, so the revised install procedure. Now, if you go to AWS, it's the same thing. And the more config variables you define and so on, it can then start provisioning DNS and so on. I'm not going to go into that because the focus, I think, right now should be just on getting the instance up on an IP. And there's no additional configuration. It's just the simplest way. And that's what I'm going to encode into the documentation onto the site, hopefully before next week. Just very precise install instructions to make this easy. Okay, so then I want to go over a couple of pages I put up just to go over as an overview of sort of what I've planned for the configuration system. So in IO-DevCom www, I'm starting to put markdown pages where I'm collecting overview information for different aspects of the system, and these are going to make it onto the site, and the content in here is going to be cross-linked to services and different pages, and this is going to become sort of an interactive foundation for these different concepts. So configuration is the first aspect, and I mean, I'm not going to go through all the detail, but I just want to sort of mention it briefly. So the idea is that configuration is very difficult, and getting configuration right is very hard, and getting it right to be able to modify it at different layers and have full flexibility is quite difficult. So what we're trying to do is there's a bunch of projects that Tim Caswell and Chris Cole are working on. Tim has built a virtual file system layer. He's working on a JavaScript implementation of Git, allowing us to store complete mock file systems in Git repositories in Pure.js. and we can run those in the browser, we can run those in the server, in any JavaScript container. And he's now adding the ability to store encrypted information in Git repositories that we can even push to GitHub. So I'm thinking about using Git coupled with VFS as a sort of foundational layer to provide a file system interface that's available in any environment. And on top of this, I'm looking at layering a configuration system that allows you to overlay multiple file systems. So the idea is the way Docker works, for instance, you have one root file system at level 0, then you can layer a new file system on top, and then when files are searched, it's going to go through the file system layers one by one until it finds the file. And we can layer something like this in a similar way, where we have one file system for our root configuration, one file system layer for our sort of runtime configuration, one file system layer for live status information, and so on. And we can layer these file systems, and each file system will include a bunch of JSON files. And these file systems are distributed across all nodes of this system. And when a node accesses these layers of file systems, the JSON files in the different layers get merged into one solid object. So when the JavaScript logic, this JavaScript code that needs the configuration information or needs to react to other events happening in the system, can subscribe to events on this JSON or JavaScript object, and whenever anything changes in the JSON files in the underlying structures, that JSON object will get updated, and we can get all these events through in real time. And this is the foundation of the configuration system that that I'm coding in, and we're not far away from getting this working. And I have everything working surrounding this core layer, so it's just a matter of getting this thing implemented. So I see it as it sort of generates a stable system blueprint, or you could look at it as it's a system abstract system tree. I think I have that somewhere. So instead of an abstract system tree. So we use native configuration files and format them into JSON structures that are very close to the native formats. So the idea is to not lose any information between the native format and the JSON structure. If you already do any generic markup here, you're going to lose information. So the idea is to have a JSON structure that is an absolute equivalent to the native format, say an Apache configuration file or whatever it may be, any native configuration file, and we have an exact JSON structure, and we should be able to go back and forth really easily here. And then the second layer takes these JSON structures and abstracts them into common patterns and common structures that we can then compare across these JSON structures for the purpose of creating this abstract system tree. And from this abstract system tree, we can then go back to these structures and the original configuration files. And this path back and forwards, I'm encoding, and this is sort of the foundation. And this abstract system tree, it's a matter of how much each component subscribes of how much information they want. So they may only want very little bit of information, or they may want a large part of the tree. So it depends if you're runtime node or developer tooling or whatever, you can subscribe to different amounts of information. So for the user experience, and this is very important because this is a whole dynamic system and property usage and everything like that is tracked. The user flow I envision is the user clones Develop Companion. He runs one command to install it locally, and then when the user is using the command line interface, whenever a new component is encountered that uses a new property in the configuration system, then it will prompt the user to say, hey, I'm this component, I want to use this property for this purpose, and I need this information. So the user can then enter the information manually on the command line, or through an environment variable we can set a nomadic service that will fill in that information dynamically as the user gets prompted in the command line. Once the instance is launched and the admin opens, the user authenticates in the admin, and then whenever the user encounters a new component in the admin system, the same process will happen. So underneath, it's using all the same tooling. So when every new component is encountered where the user needs to make a decision, a contract, some kind of decision about permissions to give to that component or whatever, the user is prompted to do that, to authorize that. And then once it's authorized, it's encoded into the system tree based on the user's profile, and then additional nodes in the user and so on, future uses are automatic, and the user doesn't have to reauthorize things for that component. And again, this can be layered and pre-configured and pre-authorized for certain users and profiles and groups. And I mean, there's tons of options here. So that's the basis. And then this foundation layer can be used for all kinds of things within a system if we can get it lightweight and fast enough. Okay, so that's a very broad, brief overview. Any questions at this point, or?
No, just continue. That's
okay. I mean, this is just brief, and as I now code things in, this page is going to make it onto the website, and then I'm going to link things in and provide real practical examples where you can play with these concepts. Okay.
Right.
The next thing is containers, and containers is places where code runs. So within Develop Companion or the system I'm building, everything runs within a container. So we define certain containers where we want code to run in. So we have, and containers are more logical containers rather than physical containers. So logical containers, I mean, Ubuntu to me is a logical container, and we can lock that logical container down by limiting the API that we use to interact with that component. So we can either use the full file system API, or we can run the file system API through a virtual API that restricts certain paths and so on, updates permissions. There's various ways to manipulate how you interact with a container. And by default, there's no restrictions, and then we can layer more restrictions in. So initially, the target is Ubuntu on the server side with Node.js. We want to run it on AWS and DigitalOcean. So this is where we are now. Client side, we're on Mac OS X, browser Google Chrome, JavaScript. Any modern browser should work. And on the client side, we can also run Node.js. And this is on the user's developer side. So these are the things I have planned short term within the next couple of months. So these are all the containers I want to support. So Ubuntu, that's there. So I want to support Zen PHP on the server, Tomcat Java, Phantom.js through JavaScript, and Mozilla has a new runner too, Sweet.js, I think, and a few other providers, a few other hosting providers. On the client side, I want to support Windows, any Unix, Firefox, obviously, and then any browser. And then specifically, I'm going to get into soon these extensions. So I want to be able to control Google Chrome as a container. So this is where the profile configuration comes in. Firefox is now a container, and a container to me is a Firefox profile. So I'm going to start coding this out by creating a Firefox container as an example, and how to dynamically launch containers for the Firefox browser, and then you can load browser pages, open tabs, configure tabs to pre-open, or extensions to pre-install as part of the profile. So Google Chrome DevTools, Firefox DevTools, and Firebug. So these are containers I want very soon. And then later on, we want to support any browser. Once we can start compiling things down to older JavaScript and so on, we can support older browsers on the client side. And then Node WebKit I want to support as well for a more integrated solution with Node.js to move more towards the sort of integrated application layer. And there's a whole bunch of platforms a whole bunch of JavaScript platforms that I actually want to support. There is, I have a list here. These are all the platforms I want to support. So there's a whole bunch of JavaScript platforms, and there's a whole bunch of different types of loaders and so on. So these are all different containers that are now going to be implemented bit by bit, and the system can accommodate all this stuff because it abstracts all the code and boundaries and everything at the right place. So based on demand, these are going to come in bit by bit now. Okay, so
Um, I don't know if this should be part of this, but what it means to support a new container. Like, can you explain what kind of work you have to do to support, I don't know,
Okay.
Firefox browser?
Okay. So Firefox browser. The way to build a container is you build a service. So we're going to call the service whatever we call it, Firefox browser service. And as part of the service, it would install, in this case, for development, it would install locally on my OS X system. So as part of the bin install, it would install this service on the local system. And then to develop that service, you would create a little Node.js scripts together with unit tests to create Firefox profiles and launch them, and and manage the Firefox process in terms of which browsers have been launched and to be able to kill them and expose that through an API. Once it's exposed through an API, then we make sure that that API complies to the interface that I've defined for manipulating a container at a basic level, like start container, stop container, or something like that.
Right.
And then as soon as that's there, then in the admin, there'll be buttons where you can say start container, stop container for Firefox. So this container page here is going to, for the Firefox browser, as soon as it's implemented, going to have a button here,
Right.
say more information with documentation on how to load it and samples and so on. So
A
that's
list of
why,
all APIs supported for that container.
exactly. And it's going to be a matter of you can reach in to the raw APIs or you can use the more abstracted APIs. And that's a pattern throughout the system. You can always reach all the way through to the lower level APIs if you need to, or use the more abstracted APIs. And this Firefox profile manager, I'm going to be working on in the next couple of weeks, and this will be a good example to sort of start tying all this stuff together. So yeah,
Right.
so that's that. And and then I'm going to work on a few examples pretty much right away. So I want to pick some projects we can start deploying onto the instance. And as soon as these projects are online and I have like 3 or 4 or 5 sort of frameworks deployed, I'm thinking like Mean.js, for instance, which is an Angular project. And Angular seems to be moving ahead pretty good right now. So we can support a Mean.js application. We can incorporate, say, the Sales.js database abstraction layer. So I want to get some framework examples onto the instance and start tying in some of the tooling so you can see how you can interact and build an application using some of these frameworks on this instance. And another example is the to-do MVC would be a good example to incorporate this, where all these user interface frameworks are then on the instance, and then I can tie in some of the meta tooling and automatically pull out routes and hook into the APIs to provide editors for content pages and all kinds of things. We can start layering into this. So these are sort of sample projects I want to start getting on the instance, especially when it's for people to start playing with.
Right. So for example, like Code Mirror project could be also
Yeah,
implemented as a container,
right.
which then I can use inside a page together with other containers.
Exactly. So CodeMirror to me is an editor, and I'm actually going to have so a CodeMirror would run within a container. Containers are more generic. Containers are like a browser page or anything like that. CodeMirror would specifically be, and I have this concept, it's an editor component. So you can have, by default, like all these pages that you see here, they're going to make it onto the admin system, and by default, they're going to use renderer components. And then when I'm logged in as an admin, I can click Edit here and automatically swap out the editor component and load the source file in to make changes right in the admin. And when I click Save, it'll commit it back to the repository. So that would be an example of the CodeMirror editor and that CodeMirror or ACE, or I want to support a few. And then again, I'll try and abstract the APIs so we can switch out the editor and so on.
Right.
So yeah, so that's, and once the editor's on this instance, then I think things are going to start getting really interesting, because then you don't need any local command line tooling anymore. You can just go online, create an instance, log right into your instance, and make changes and see everything online. You don't even need anything local anymore. And that's how I envision a lot of people working on, say, contributing to Firebug, where they just create a container online, make their changes. The whole process is managed online, and then if they want to get into more depth or whatever, they can clone the system. But otherwise, they would just work online.
Right, right. And what is the difference between a container and component? Like component is something which is running inside a container?
Yeah,
Or,
yeah, exactly.
and how do you define what is component and what is container? Why the code mirror is not a container? Why it's
It's
a
both.
component?
It's both, and that's a very good
Both.
point. So,
Okay.
so I would consider the CodeMirror as a container as well for plugins, say, for CodeMirror. So um, that's where things get layered, and you're totally
Okay.
right. So Ubuntu is a container, Node.js within Ubuntu is a container, um, AMD running within Node.js is a container. Like these are all sort of layered containers, and the idea is that a container can track its loaded dependencies, and that's really the primary role of a container. A container can be broken up into multiple sandboxes, and each sandbox can track its dependencies, and each sandbox can be reloaded. And the and I have a page I started, but I want to go through more detail here. I want to add a bit more detail, but I can. So this is the aspects page, and these are the aspects of the system that right off the bat I'm considering in terms of the infrastructure. So we have the persistence layer, then we have data containers. So persistence is the physical persistence layer. Data containers are your tables and logical data containers, not the data itself. Then you have a whole bunch of native implementations of APIs. Then you have a whole bunch of primitive implementations that use the native implementations, like promises and things like that, things you can layer on top that are sort of low-level primitives. Then you build a whole bunch of abstractions using those primitives, and then the abstractions can be used in multiple domain-specific languages. And then domain-specific languages run in runtime containers. So the runtime containers is like Ubuntu, Node.js, all this kind of stuff. CoffeeScript would be a runtime container. It would be a domain-specific language that runs in the compatible JavaScript runtime containers. And each of this layer can export capabilities, and then the runtime container and the capabilities and needs of these layers and objects can be compared to what the containers provide. And you can find automatic matches of, say, if you write a component in, and you can get an analysis of which containers it'll actually run in, and then you can press a button and actually try it.
Right.
Programs.
So
Sorry, go ahead.
does it mean that every aspect in this list corresponds to an interface?
Yes.
Like
right. An interface, configuration files. These aspects are very difficult to abstract in a uniform way. And this is what I've found throughout system development. Every abstraction you make is unique. If you try and have commonalities between abstractions, you're going to run into problems. You can have abstractions within a very specific domain space where abstractions can stay similar, but beyond that, abstractions are hard to get right. And what I've chosen here is to as a foundation for each abstraction, I'm going to use metadata, which then links in more concrete code and more concrete conventions and things like that to make things easier. And I don't know how that exactly is going to be split out and all work, but these are the layers I have to recognize, and these are the layers that, yes, you have to be able to address through API, through metadata, and whatever. So programs are groups of runtime containers. So for instance, a program to me would be a Firefox profile that it can preload a Jetpack extension that can preload dynamic JavaScript code, and maybe that loads a browser page with another component in there that can then automatically communicate with the JavaScript code in the Jetpack extension. So there's a whole bunch of components involved there, and if you try and locate that into a project, your project is going to get very unwieldy very quickly if you have all that plumbing code and all that in your projects all the time. So that's the whole point of programs. The whole idea of they have generic containers that you can then, through configuration, customize and load in your own code and work with the various APIs that are exposed. So I see various generic programs being developed for all kinds of things that you can then, through an application, fine-tune for a specific purpose. So you have your generic programs, you fine-tune them by building an application, and an application is then the pure business logic. So metadata and then plumbing code that links other components together. Scripting code and UIs to link different components, all kinds of things. Distributions are programs tuned for a specific environment. So if the program is generic enough, it can run on Google Chrome in what I just said, Google Chrome and Firefox. And if it's generic enough, we can have two different distros that tweaks this program for the different environments, irrespective of the application. So the idea is to get these layers all decoupled so that you can focus on one layer at a time. And ultimately, users will primarily focus on application layers and audience layers. So audiences are applications tuned for specific user groups. This is where like permission profiles and all kinds of other configuration stuff comes in when you want to start providing a group to an application to a group of users. Different authorization layers and so on. Then when a user interacts with an application at any of this layer, at any of this level, the user interacts with it through a profile. And the profile holds specific keying information and information about the user that's interacting with the system. So we need certain keys and so on to start namespacing data that gets generated when the user interacts with the system. And that's what the profile layer is for, to coordinate all those namespaces and so on. Networks are formed, so a profile is a user using a system or an automated system using a system. There's no difference. So whenever you interact with a system, you go through a profile. And the profile attaches more information to you, makes you known either anonymously or publicly known who you are, and can track information when you interact with the system. When you own a profile and you make relationships with other profiles, you create a network. So the network is then agreed upon and broadcast profiles for and contracts for profiles. So say I have a profile for the devcomp.io site. I would have a public profile that broadcasts on the domain devcomp.io that anybody can publicly access the site. So that would be one profile. And then if someone accesses Develop Companion after they've logged in, they would have a more specific profile with their username that gets layered on top of the generic profile and then customizes things from there. And that user then can inherit networks that are already defined by devcomp.io, or the user can define their own networks if they say, hey, I want to now collaborate with this person, and I agree to get code updates from them, and I agree to push code updates to them, and so on. And then the data is totally separate. So the data is stored in data containers. And the whole idea is that the entire system provides generic data containers, and the profile includes encryption information. So together with the profile residing on the user system, it can potentially encrypt all data and store all data on any of the server components in an encrypted fashion. And any of the server components would never have access to that data. And that's a basic capability built in, and then it depends to what extent data needs to be accessible on the server to services and so on. And the way I envision that, say, if a user authenticates on the client, they have a bunch of data that they're editing, it gets stored encrypted on the server. If they then run a server process that needs to decrypt that data to run a service, like a build service or whatever, that component would ask the user in the admin saying, hey, I need to decrypt this data to do this task, do you allow that? Always, just this time, under certain conditions and so on. So you can then script that elevated data access authority and delegate it to servers if you trust those servers or whatever. But the point here is that you have complete control over configuring who gets access to what. And it's user-driven from the user's perspective. And the entire server layer is all driven based on these profiles and configurations, not through hard coding APIs and so on. These are linked declaratively. So this is sort of a very broad overview of sort of the abstractions throughout the system. And now I will be, as I build natives and primitives and containers and tie them in, I will be linking them in here and providing links to APIs and so on, and building out these min as I said before.
Right. So actually the question is right, but so if I'm building a system, using these containers and components, then I'm configuring them using that abstract system tree, right? So all these configuration files which are related to these components are stored in that abstract system tree.
System tree, right. So you can...
We went through before.
what's going to happen is, um, and this is where this layer comes in. So
Right.
um, first, we convert the native formats to the JSON structures. So what I envision here is that when you write a service, say for a Firefox profile or for anything you do, you declare either a native configuration file or a JSON configuration structure, and you define it for whatever purpose you need in your context for your component. Don't add anything in that makes it more generic. Don't add anything in that makes it more usable in a bigger context, whatever. It should be, properties should be named without any namespacing or concepts in there. Everything should be concrete to the service you're building.
Right.
Then,
So,
then the next layer is to have a converter that uses that basic format and upconverts it to a more standard structure that can be absorbed into the system tree. So what I have is, the way I do that right now is I have, say, when I provision an instance on AWS or DigitalOcean, I have an object that has a property called _raw that holds the raw configuration from DigitalOcean and AWS. And then the top level properties of that object are IP, private IP, host name, things like that. So things that I can have common across the different nodes, across the different services. And I see this as a gradual process, and most importantly, the configuration system and tooling in this admin is going to help you with that. So I'm going to have a viewer that will visually show you the different layers of configuration, where they're merged, where values are coming from, so you can visually see how the whole thing comes together. And you can then choose to use JSON structures that are very close to your implementation. Like I said, this is how everything starts for me. And then once you have 3 or 4 services that essentially do the same thing and could be combined, you then come up with a combined API, and you then you implement converters for these formats for that generic API for these services, and then all the APIs on the and then all the services would support that API. That is a common workflow that is true for every component and many types of tasks that need to be done within this system. So it's a generic workflow I'm encoding into this whole platform, where you can have containers, and containers can use abstracted APIs and then also more specific APIs, and they can tell you how far apart you are, and all these kind of things we can put into the admin tooling to help with collaborating on APIs and making them more generic. And that's essentially, foundationally, the entire point of Developer Companion is to arrive at sound foundational APIs for a system that can use an abstract system tree to manipulate systems in real time. And the entire collaboration on the API level is something I'm going to be spending a lot of time on, to basically bring 4, 5, 6, 10, a dozen projects into line. And the way I envision it right now, say there's a lot of template engines out there. There's like, let's say 50 template engines out there for JavaScript. So what we would do is we would start, say, 10 people say, okay, I'm going to build services for these engines, template engines, so we now have 10. And then what I see happening is we would go through the different implementations of these template systems and look at which template systems are similar. So there we'll probably find like 3 or 4 different types of categories of template engines. And then we would define more abstract APIs for those 4 groups. And then over time, make these template engines compatible with the configuration and API designed for that group. And over time, template engines and template implementations will die because they don't adhere to these APIs, or they don't get maintained or whatever. And then certain implementations will become very popular as reference implementations for certain APIs and so on. And this translates to all components. And that's the idea, that we start out with the raw stuff people did. We have parsers for all the metadata and so on. So we can start exposing commonality. We can start exposing metadata so we can see commonalities, and then we can start saying, okay, we've got to break this up into these 3 or 4 APIs. Like an example would be an asynchronous and synchronous file system API. So those would be 2 major splits. And you would never try and combine those two. We should just have two different APIs for that. Yeah.
Right.
Okay, so here now, so we called PIO deploy. So Firebug is now deployed. So if I go now PIO open, it should open up there. And then here again, we have Firebug test manual. And if we now look at what IP that Firebug test manual is running on, so services test, Firebug test manual running on port 81. If I go here, port 81, there's the Firebug test system that we built. So if we go to port 80, there's nothing there, no virtual host found. So as a quick example, just to sort of round this out, let's add a little page that's going to act as the home page of the Firebug dev system as a start. So this would be then, say if we'd register domain firebug.io or whatever, I recommend we register domain, and then I can start building this out much more concrete for against a specific domain. But okay, so we want to build a little service that is now going to show, act as the home page. So we're going to go new folder, dot home. Let's call it Firebug website. No, let's call it website system. Okay, so then in here we're going to have a package. We're going to have a server.js file. Copy a package.json. Copy the server.js file. Okay, so Firebug website, glob, don't need that. Scripts, yeah. Document root path, no. We're gonna use new folder www, new file index.html, hello world. Okay. Now in here we're gonna get rid of this. Don't need that either. Okay, so now we have the Firebug devs website system. So this is all we need. So we're extending the IO pin www server. All we need is a www directory here. And then in server, we're just calling this upstream server. We're not defining our own route, any routes here. So this is just using the generic web server that just gets everything up and running really quickly. And then pio.json. So we have test Firebug. So, oh, I put this under test. I should put that under a different group. We should put that under sites. Oh, wrong one. No. Yes, Firebug website system. Okay. Project. Refresh folders. Okay, sites, Firebug website system. So we're going to take that, go to pio.json. So we have test, and then let's say sites. Firebug system, comma. We're going to depend on a couple of things. Okay, so this we're going to put on port 82. We're going to PIO proxy vhost, so manual Firebug test. We're just going to go the host name. PIO server. This one we don't want. So PIO proxy. PIO proxy is the proxy that runs on port 80 by default. So we're configuring that we want our host name. Or you know what? This is not going to work because we're running on IP, but we can run it by port. Right. So if we were running by host name, what would happen is it would now, if we go to the host name flat, it's going to direct to this server here. But because we're running by IP, it may not find that, but we'll see if it does. Find one. Okay, PIO deploy Firebug website system. Done. So that was pretty quick, maybe too quick. And then we're going to deploy. Right now, because we're declaring a plugin here, config plugin PIO proxy. I have to actually deploy the proxy right now to update that route, but that'll be dynamically based on just deploying the Firebug service in future. Okay, let me just deploy the proxy here. Okay, refresh. Okay, yeah, no, that won't work. So I have to look at that. But if we look at port 82, we should see hello world here. So I'm going to make sure that this shows up as a plain vhost. That's probably just a simple bug fix. And then once the hello world is up there, so now we're going to say PIO spin, for instance. And now we can go index, hello world, and then we say ahref. Manual Firebug tests, and I have to see how I can get the IP in here. Fix that after the call to get this IP dynamic. Mm-hmm. But we just published that service there. We should be able to refresh here. Manual Firebug test. Click on it. Bam, you're there. Nice. So you can see there's a few more sort of minor nicks and whatever like that, but then you can start making progress real quick here. And especially when some of these features are coming. Something I mentioned last week, or I did after the call last week, is I started a new service for Browserify. pin.io, and there's a new service called Browserify, and the Browserify service is an example of how I want to start transporting modules to the browser. So in www examples Browserify, it's simply going to go so the Browserify service in package.json down here, I don't know if you can see this, you have IO pin server Browserify. Then you say, I want to declare bundles. I want to declare bundles from the examples group, and I want to find them in www examples Browserify, and the entry point is main. So this works, and this is an example to incorporate an automatic bundler that will automatically bundle static resources upon request. And Browserify is the one, and I'm going to tweak this and add to it, and I have a couple other bundlers I'm building in. And the idea is that you pull out raw JavaScript files from the file system, bundle them whatever for consumption in the browser in a better context, so it can be loaded into a container in the proper format. So once it's configured like that, then here's the sample. Here's the main.js, and main.js is simply require foo. So this allows you to not have any of the A&D wrapping and any of these other wrappings. So we can write modules using strict requires like this, and then when they come to the browser, when you load them in the browser, you reference them like this. So it's going to come from, if this service is mapped, then you're going to say simply, I want to fetch a bundle from the service ID. So in this case, we want to fetch, this is the example bundle. So IO pin server browser verify service, the examples bundle, and this name. So it's just remapped, and then when I pull this in, it's going to be everything bundled. So in the admin system, as soon as services are exposed, you can then start calling declared bundles just by declaring the ID and then the logical name to a mapped a bundle, and you can start pulling these in. And that's how I'm going to do widgets and all kinds of stuff. And the next thing I want to do is tie in Domplet and Domplet renderers and have a little container where we can start building out a little console that dynamically renders JavaScript objects based on the Domplets, just like the Firebug system does.
Right.
And I see that as the absolute foundation, to have a dynamically rendered console that pulls in these Domplets and some of these files dynamically as the absolute starting point. And then we can see how we can restructure all the Domplets and templates and everything within Firebug into isolated components that we can then load in, isolated, and then link at runtime.
Right, yeah, true. All these templates could be shared.
Exactly, and then they're usable on the website. Yeah, and they use them on the website. Then they're usable on a web page as well as on the Firefox extension. And this is this is the absolute key and the whole point of this whole thing, that you do your development using a web page, and then or other containers, and then containers that are most suited for your development workflow. And then when it comes to actually testing it within Firebug, that would be a separate process. And the idea is that your development workflow has sufficient testing and sufficient depth that when you then run it in the final Firebug container, you're not going to run into any issues. It should just work. And so once we have some of these Domplets and some of these things pulled in dynamically and have a console working on this instance, then I see incorporating, creating a Firebug branch with, or maybe a new project based on the Firebug SDK, where we can run one of these containers within the extension that will then load, say, that console we're building here as a separate panel into the DevTools. And then instead of showing the panel on the admin, so instead of having the console logging panel in this admin here, it would log to the DevTools console.
Right.
And we should be able to pull in renderers dynamically, just like we're doing in the web page.
Same renderers, yeah.
Once we cross these boundaries, we can then look at the whole security aspect. So within this admin, security is handled on a global level. So just by accessing the admin, you're authorizing, you get a session ID, and then you're in. When you then start incorporating into a different container, then we can look at locking down the security aspects and asking for permissions to do certain things depending on the APIs you use and all kinds of things. So by default, it would just run and pull in whatever we need, or based on what we configure. But the idea is that you can pull in dynamically rendered, you can pull in widgets dynamically. So if the web page declares I want to use this rendering widget for this object I'm logging to the console, the console system should be able to load that widget in dynamically, based on some rule or whatever.
Mm-hmm.
And yeah, that pretty much sums up today.
Cool. That was a great session. Very informative.
Great. Yeah, it's finally getting there to be more friendly. So what I'd love to see is if you could, before next week, try and get a DigitalOcean instance up.
Right.
And then that's the first step. And then what I'm working on next is a continuous integration service together with an update command. So whenever I make changes, it's now going to start automatically testing it against the various clones I have of this system, and automatically update the Firebug dev system project and things like that whenever changes come in. And then on your side, it should simply be a matter of running PIO update, and you should get everything up to date, deploy everything, and you're back to square one. You can continue.
Right.
So that's the process I'd like to fine-tune over the next couple of weeks. And then as soon as the update process is in, there's going to be an issue tracking system that's going to be part of the admin that'll allow us to track issues across projects. And that initially is going to work with GitHub, but the adapters are generic enough that we can tie in Google Code issues, like all the Firebug issues, for instance. And what's interesting there is then within the Firebug issues, once this is integrated, in the Firebug issues, you can start tagging Firebug issues with metadata and keywords that are defined within the Firebug dev system. So if you have certain issues that belong to certain projects or whatever, we start tagging them, and they'll start showing up on the documentation pages or whatever for these different projects right in the admin here. So you're going to see all the issues logged in the central issue tracker for whatever project is using. Then the issues are split out in context and also potentially sorted based on priority and different development phases and whatever as part of this dashboard, wherever it's relevant to see those issues. And then ideally, you click on the issue, it loads your cloned instance, loads everything in context for that issue, you make fixes to that issue and submit a patch automatically. And that's the workflow I'd like to hone in the next 2 to 3 months to get that completely fluid.
Mm-hmm. Cool. Sounds good.
Great. Okay, so that's it, and we'll catch you next week.
Cool. Thank you. It was great. Great session.
Great. Thank you.
Thank you. Bye-bye.
Bye.